Assalamualaikum warahmatullahi wabarakatuh. I will present about my final year project. My topic is evaluation of Spotweld failure model in RADIOSS Roof Resistance Test FMVSS 216. My name is Muhammad Dini Lepewu Rehan. Introduction. In the automotive industry, fatigue resistance and durability are extremely important. The failure of some spot weld and joints in a vehicle body can result in unwanted noise and vibration inside the vehicle as well as a reduction in crashworthiness. Problem statement. The current FV model has error in strength to weight ratio which is SWR equals 5.41 compared to the actual test result SWR equals to 4.10. Main purpose of the research is to find the right Spotweld failure model behavior to replace the Spotweld failure that has been allocated in with crash simulation in RADIOSS. Objective research to optimize the Spotweld failure model available in the RADIOSS definition library comparable to the actual resistance test according to FMVSS 216 reading of 20% of error. Second one, to compare strength to weight ratio SWR result between current FE model and updated Spotweld failure model. Scope of research. To use alpha hyperweight as a medium in converting the finite element of the Chevrolet Silverado model from LS Dyna to RADIOSS format in order to run a crash simulation. To describe the parameter setup by FMVSS 216 that has been used in roof crash impact simulation and modified to the actual position car roof side during an accident. Lastly, to optimize the vehicle behavior and deformation properties that we analyzed from simulation. Literature review. The frontal structural crashworthiness structure design process is also called crash energy management design, which aims to monitor load transformation path and optimize energy extraction. This is a pillar is major critical when accident. Side structural. Side impact as the chance of upper limb injury are greater than in frontal injury, in frontal impact. The door beam should therefore be stiff enough to take the load on. The B pillar also takes up the load in case of side barrier effect. This one is B pillar. And this one is roof part. The two part is also a critical part when the roof crash test. Roof strength crash test. Roof crash is a fatal accident and can lead to death. The strength of the roof is measured in the test by moving an angled metal plate down at a steady pace on one side of the roof and testing the force needed to crush the roof. The force exerted proportional to the weight of the vehicle is known as the ratio of strength to weight ratio SWR. Type of Spotweld infinite element. There are two types of Spotweld infinite element. The first one, point to point, P2P. Four different P2P for Spotweld modeling elements, which is C-rod, C-beam, C-bar, and rigid connector. The second one, area contact model, SEM. RBE3 is an element that connecting of nodes at the bearing support to single nodes on the rotating axis. The lastly, C-weld. C-weld is preprocessor that produces a shear that flexible with 12 degrees of freedom with torsion curve beam with two nodes. Strength to weight ratio. Ratio of the applied latent load to the vehicle curb weight. SWR is one way to measure the strength of a vehicle roof. Higher SWR value suggests a stronger roof with less occupant compartment extrusion. Okay, for the formula, peak SWR equals maximum applied force divided by unloaded vehicle weight. Methodology. For the model selection that I used in this simulation is Chevrolet Silverado 2014. Run simulation, optimize, improve Spotweld failure model data, compare, compare the SWR result with the actual test equals 4.10. And lastly, evaluate. Evaluate target error must below 20%. Roof strength rating boundaries is a table for the roof strength rating boundaries. The actual test 4.10, which is great because SWRs equal is over than 4 is rating good, great. Parameter of Spotweld failure model. For the roof resistance test, there are three critical parts that have impact when you crash. These are good for Spotweld failure model. The ID for the material Spotweld failure is 2,081,000. The material is low 59. These are critical parts for roof resistance test called P pillar for Spotweld failure model. The ID for the material Spotweld is 2,095,000 and the material is low 59. Spotweld in B pillar has been shown. These are critical parts for roof resistance test called A pillar for Spotweld failure model. ID for the material Spotweld is 2,089,000 and the material is now 59. Result and discussion. This simulation video. Okay, the angular metal plate move and we crush the roof and the roof we crush and that's why the windshield is broken. As you can see, the windshield is broken because the impact for the angular metal plate. Okay, Spotweld failure model data. The actual test that I just say, peak force 94, SWR 4.10. Next, graph of before applied Spotweld failure model. Okay, maximum force has been developed during a crashing action. The force during maximum force is 123,929.78 Newton at 0.1119 seconds. The total for SWR before applying the Spotweld failure was 5.38. Percentage error for this test before applied Spotweld failure model is 31.84% for peak force and 31.21% for strength weight ratio SWR. The second one, graph of applied Spotweld failure in Spotweld failure model. Maximum force has been developed during a crashing action. The force during maximum force is 116,226.73 Newton at 0.1181 second. The total for SWR to apply the Spotweld failure model is 5.05. Percentage error for this test after applying Spotweld failure model is 23.69% and 23.17% for strength weight ratio. It is a maximum force. And lastly, graph of applied Spotweld rupture in Spotweld failure model. Maximum force has been developed during a crashing action. The force during maximum force is 113,028 Newton at 0.1136 seconds. The total for SWR after apply the Spotweld rupture is in model is 4.91. Percentage error for this test after apply Spotweld rupture in Spotweld failure model is 20.24% and 19.76% for strength to weight ratio. Okay, as you can see, this is a maximum force. Comparison. These are table for the comparison include the actual test data. As you can see, peak force in kilonewton, actual test data is 94, but the lastly after applying Spotweld rupture in Spotweld failure model is 113.10 kilonewton, which is a 20.24% for the peak force percentage error. And for the SWR, actual test data 4.10 And lastly, after applying Spotweld rupture in Spotweld failure model, I got 19.76%, below 20% the target that I want. Conclusion. Summary. To optimize the Spotweld failure model available in the RADIOSS definition library comparable to the actual roof resistance test, according to FMVSS 216, within of 20% of error has been achieved based on the analysis using Hyperworks. The comparison of time to weight ratio established a result between current FE model and updated Spotweld failure model has been achieved and been approved. The updated Spotweld failure model has good rating of 4, which is a grade based on roof strength rating boundaries. Okay, that's all for my presentation. Thank you.